Okay, so this is our second class, and what we're going to try to do is go over a few questions that people asked about from the homework. And so I'm going to do that first, and then I'm going to go over the new material. Let me see if we can get this. Okay. I'm going to rewrite this top one. This one said, how do you write 10 subtracted from y? Now, when they use the words subtracted from, this particular phrase, most of the time, when you see something, it would be 10 minus y, and that would be the end of it. But when you see the phrase subtracted from, the order gets reversed. So this is one of the few exceptions where what you see first is last and what you see last is first. And so let me see, it's frozen. Let me see. Let me go back. So what I'm saying is the phrase subtracted from is an exception to the typical rule. And so this would mean you would have y first minus 10. So I think I'll do a bunch of things about these phrases, but this is one exception, and this is why somebody had trouble with it, because it's not the normal thing. So let me just let that be. Next one here was an example. This was the number, and they wanted it in expanded form. So this means you have to say what each thing is. Now, this is 74, obviously. This is 805,000. This is 307 million. So you really want to start over here. And so this is, just so that we're clear, this is the million place. This would be 10 million, which we don't have any. And this would be 100 million. So the first thing you do with this 307 is to say, well, what is each one worth? And so this is 300 million. So 300 is this. But to call it in millions, you've got to add 1, 2, 3, 4, 5, 6, so that it looks like millions. So this is the millions. Once you get past the 6, you're in the million slot. This one here is just plain 7 million. So that would be 7, comma, 1, 2, 3, comma, 1, 2, 3. Okay. Then we go to this. This one here is thousands. This would be 10,000, but we don't have any. This would be 100,000. So I'm going to just keep going this direction. So this is 800,000. So that would be 800. To get it in thousands, we need 3 more zeros. And then you look at it. Is that 800,000? Yes, it is. So we're good. This is just plain 5,000. So this would be 5, comma, 1, 2, 3. Okay. And finally, this last little bit is just plain old 74. You see how my pencil froze? Sometimes it'll come out, sometimes it won't. Ah, there it did. So this would be the ones, and this would be the tens. So this would be 710, so that would be plus 70. And this would be just 4 ones, so that's just plain old plus 4.
Question, what if it's like 33, 33, like instead of 307, It's 33 and 7. 33 and 7. I don't know how to.
337?
Yeah, because that's like.
Okay, let's do that one. 337, comma, 1, 2. Let's just focus on
Yeah,
that.
yeah.
Okay, so, you know, these are the thousands.
Uh-huh.
These are the millions.
Uh-huh.
This would be million. This would be 10 million. And this last one would be 100 million.
Right.
So to get into the millions, you know, you've heard of 6-digit places. This is, so the 300 would be 300, comma, 1, 2, 3, comma, 1, 2, 3. Then you stare at it. Let's see if it's gonna pop. It's coming, is it coming? No. I'll give up on it. Technology. So there it is. So that's 300 in the millions place.
Mhm.
This would be a 3 in the 10 million. So that's 30 million. Notice how, yeah, that would be 30 million. And this last one would just be plain ordinary 7 million. So it's 7, comma, 1, 2, 3, comma, 1, 2, 3. So notice every one of these had 6 zeros trailing
Okay.
so that we got them all into the millions, right? And the
So
first one was
million.
300, the second one was 30, the third one was 7. Does that do it for you?
Yes. So millions have 6 zeros.
Yes,
Right.
yeah.
And what's billions? How many billion? How many zeros?
Billions would be the next batch.
So that's 7 zeros. Does it go up one?
So um, if you had to go to billion, which, you know, I don't know, maybe we do with the national budget. When you go to billion, it's the next 3. So these are the millions. The next batch would be billions. So if you're doing billions, you're going to have 9 zeros.
Oh, okay. So the zeros go up by 3.
Yeah, but
Okay.
millions is just 6 zeros.
Okay.
Okay,
I got it.
got it.
Thank you.
Thank you. Okay, so the next question was the associative property. And when they ask you for the associative property, this is for addition. They're basically saying, they want to keep the same order, 4 plus 5 plus 6. They want the same order. What they want to do is move the parentheses, which is telling you what you do first. So in this particular case, you would be adding the 4 and 5 first. But in this particular case, you would be adding the 5 and the 6 first. It doesn't really matter. You would end up with the same answer regardless because it's all addition. But that's the way they wanted you to answer that question. Okay, that's the associative property of addition. Okay, this next question had to do with this. This was the number. I think somebody's on the phone and they need to turn their video sound off. Yeah. Okay, so this number here, they wanted it in words. This is kind of like the one we just did, isn't it? So these are all in the thousands. So this is 300,000. So notice with thousands, you just need the 3 zeros and then it's 300. This is 0, so I don't think you need to bother with it, but this one is 5,000. So that would just be with a 5, comma, 1, 2, 3. Okay, now it gets easier. This is 900. This number here, the 6 is 60. And the last number here is 4. That's expanded. So they wanted it in words. I did it expanded, but in words, it would be 305,964. That would be words. Does that help?
Pardon, I beg your pardon, in words?
Yeah,
The thousand has a hyphen in it?
305,964. If they
Okay,
wanted it in words, if they wanted it expanded, this would have been it. And I got carried away.
okay, thank you.
Yeah,
Would the 64 be hyphenated?
it would if you're in words, yes.
Okay.
Good job. The 64 would be hyphenated. Good. So here was the problem about your bank account, the next one. And the next one had to do with, let me see if I can make this fly. So you had $484. This was the problem. And you put in a deposit of 142. So that's to the plus. And so that would give you 4 and 2 is 6. This is 12, carry a 1, 4, 5, 6. So I'm up to this. But then I wrote a check for $34. So when you write a check, your bank account goes down. So we need to subtract. So 6 take away 4 is 2. And this, you can't go 3 from 2, so you borrow. And this is now 12. Take away 3 is 9. And then you'd borrowed 1, so this is 5. So it's 592, but then you wrote one more check, which was 167, so that's a subtract. So this one needs to be borrowed. You can't subtract 7 from 2. So you take 1 from this, and so it's now 8, but this is now 12. So 12, take away 7 can be done, that's 5. 8 is what it is now. Take away 6 is 2, and 5 take away 1 is 4. So that would have been your final answer. Now,
I have a question.
I was going to show you another way to do it. Go ahead, ask your question.
So what if there's like a 0 like in between and you can't like borrow from the number because there's
Borrow. Let me 407 take away 382. Does that do it?
yes.
So 7 take away 2 is 5, no problem. Right? But
Yeah.
you try to borrow from the 0. Well, you still do the borrowing. You take
Well, not like that. Like particularly if like the number in the back, like say it was like the 2 and the 7 was switched and you couldn't subtract the 0 from the like,
okay. So
yeah.
402 minus 387, is that what you want?
Yes, like that.
Okay, so you were stuck right or at the very beginning.
Mm-hmm.
So you try to borrow from this, and so you think of this as a 10, and so it's really a 9, but you had to borrow again here.
Oh, okay. I see what you, okay.
And so now this becomes 12 take away 7 is 5. But when we tried to borrow from this, we had to think of it as a 10, taking away 1 is 9, but then we borrowed again. That's a good problem, actually. 9 take away 8 is 1, and 3 take away 3 is 0. So the answer is just 15. But I'll tell you what, when you get a problem that's annoying like this, and I'll tell you what, I ignored, I felt annoyed about this problem myself.
Mm-hmm.
I would then check it because I can't stand it. And so
Yeah.
I would add 7 and 5 is 12, carry a 1. 8 and 1 is 9, and 1 is 10, carry a 1. I would check it.
Mm.
And then
Got it.
I'm happy. And now I'm happy with my 15. so that I
Mhm.
didn't mess up.
Yeah, that makes sense. I got it.
Okay, good job. All right, and finally, the last one was this. Okay. Now, this is the distributive property. Now, I want to do a different problem and then show you why we do this. So if I had 3 parentheses 7 plus 2. Okay, so ignore this problem. I'll just move it out. So you have 2 ways to do it. You can add these two. 7 and 2 is 9. And then this is 3, and we have to assume, we haven't done multiplication, but we have to assume 3 times 9 would be 27. So that's our final answer. But with the distributive property, you are allowed to do this. 3 times 7 plus 3 times 2. Okay, 3 times 7 is 21, and 3 times 2 is 6. And lo and behold, when you put those together, you get 27. So why would you do it the hard way when you can do it the easy way? It's a trick question. You do things the easy way if you can. You don't go for hard. But what we're finding out is doing it piecemeal like this worked. Why did I do that silly problem? Because in this problem, I'm unable to add this and this. This is a 7, nobody will argue. This is letter Z, which is a number that we don't know. We don't know what this number stands for, and we may never know. So what are we forced to do? We cannot add them like I could here. And so we have to play the distributive property. So 3 times 7 is definitely 21. But this is 3 times this number Z. And I don't know what the Z stands for yet. And so there's nothing I can do about that. So somebody once taught me to make these little arcs to show, it's 3 times the 7 plus 3 times the Z. And so this may not look like a final answer, but that's the best you can do at this point. That's your best. So it's
Can you combine like terms?
distributive. Yeah, go ahead.
I'm sorry.
Go ahead.
Okay.
I was saying, can you combine like terms when there's 21 plus 3Z? Can you put the 3 together and the 21 together?
No.
Make it 24 plus Z?
The trouble is, we will get to this. There are terms, and this one is a perfectly good number. 21. This term is a Z term, and they are not alike. You can add like terms. You could add a 21 number and a 6 number. You could add those, no problem, but you can't add things that are unlike.
Okay.
This
I was asking.
never say this, but this is a rule that should have been the very first course you ever took in grade school. It's assuming that when you add 2 things, they're like. But they never quite say it. And when you get to algebra, you can't go against that. This is a Z term. This is a number. It's night and day, and so you just have to leave them separate.
So the question says is simplify. So
That's
we
it.
don't divide it by 3. We don't do that.
That's the end of it. That's simplified. For now, that's the best you can do.
Okay, thank you.
All righty. So what I want to do, we talked about the first 3 sections, and I want to look at section 1.4. Let's see if we can, see if I can get to 1.4. A lot of 1.4 is about subtraction. And before I do anything further, I want to talk about the words. So in general, this is in general, the 4 words that you might see. If you say the sum of 3 and x, the word sum means you're going to add them. In subtract, they may use the word difference. They may also say subtract. They also might say subtracted from. Okay, see if that'll pop up. I think it's my internet connection.
So difference means subtract.
So difference, yeah. So sum is used for add. Difference is used for subtract or subtracted from. While I'm at it, to multiply, it's product. So they might say, this is in the next section, find the product of 3 and 5. That means 3 times 5. Okay?
Yes.
And the last one is quotient. Quotient. That means divide. And so we wanted to have all 4 of them there so that you can definitely see all 4. So quotient means to divide. So these 4 words, sum, difference, product, quotient, get used a lot. And so in some of the problems they find the difference. So back to the one we're in, this is the section we're in, about subtracting. Find the difference of 10 and 2, okay? So to find the difference of 10 and 2, that would mean you would literally subtract them. So the difference of 10 and 2 means you're going to go 10 minus 2. Answer would be 8. Okay, so in most cases, the order that they give them to you, 10 is first, 2 is second, that's how you subtract them. And so that's what I want to do, is subtract the 10, take away 2. But then, so the difference of 10 and 2 is 10 minus 2, which is 8. The one exception is the one that somebody asked about at the very beginning of class. Find 3 subtracted from 8. This is the exception. When you subtract from 8, 8 is first and 3 is second. So this was the case where the order was reversed.
Do you have to reverse it, or you're allowed to reverse it?
This is the exception. Subtracted from is an exception. And so you're subtracting from 8. So 8 is the start. Okay?
Oh, okay.
Yeah. And so it's almost easier to learn the exceptions than to learn everything else, because most things are fairly obvious. Now, I think in multiplying, I want to do a little bit, let's see, how's our time, 10, 11 o'clock. I want to do some multiplication. Let me see if I can do. We want to try. Okay. All right. 4. So what we're interested in is how to make your life simpler. And so occasionally you get a problem that's not that hard to do. And so in this particular case, when it's multiply,
I
And-
have a question
go ahead.
on subtraction. On
Yes,
subtract, if it is subtract 3, subtract 8. When there is no that word from.
when it's not the word from,
Yeah.
then it's the normal order.
Okay.
So if you say 5 subtract 2,
Yes,
it's normal.
it's normal.
The one example that's different. So this one would just be 5 minus 2.
So if it comes when the first number is the less, like a 2, subtract 5.
You know, that's going to work for just a little while. The
Mm.
problem is this. Sooner or later, we're going to subtract more than what we have. That's how we go into negative numbers.
Yeah. So,
And so you
so
can't
if it
always
comes
take
like
the
that,
smaller
I put negative.
Yeah, and so for instance, if you had, and sometimes you won't even be able to see, 4 subtract, I'm going to abbreviate, from X, you can't tell which one's bigger.
Yeah.
And so you have to rely on knowing that this is the exception. And so this is where X is first and 4 is second.
Okay.
Okay? So
Yeah.
it seemed like a good thing to do to take the smaller number second, but sooner or later we're going to be going into negative numbers, and so that won't work anymore. So we don't want things like that. Is that okay?
Yes, thank you.
So here's the thing. When in multiplication, you learned the X meant multiply. The problem with X is that it's one of the favorite okay, I'm going to talk to Nico. Nico just wanted to talk. Is that what that message was about? Oh, they wanted a live translation. Is that what you want?
I think he said yes.
Okay, good. All right. So yeah, this will be on the screen. I hope it doesn't bother you. So the X is used in algebra so much, and it's sort of a problem. And so then another way to do multiplication is this one. It's a dot that's halfway up the number. So they call it a raised dot. That means multiply. Another way to do multiply is like this. This is 3 times 4 with parentheses around one or both of them. Okay. There is another way to do multiply. And if it's one is a number and the other is a letter, what you see between the two is nothing at all. You see something, if you see something, you're in trouble here. There's nothing there. So 3x would mean 3 times x. How's that? So these are all the ways to symbolize multiplication. But we're going to try to avoid the x because of the problem that'll come up with algebra. So now this is multiply. So the 4 what I would do is go 4 times 2, 8, adding 2 zeros. Does that work for you?
Yes.
Yeah. 12 times 100. Zeros are helpful to us. And so when the zeros are there, 12 times 100, again, I'm kind of doing the same thing. It's 12 times 1 is 12. And how many zeros do I need?
2.
2 more. Is that okay with you? So if you had 70 multiplied by 80, okay, 7 times 8 happens to be 56. How many zeros would I have?
2.
2. So you'll see I'll do that many times, trying to simplify my life. Okay. Now, so let's see if you were paying attention. Find the product of 8 and 9.
72.
Correct. This means multiply. These are the two numbers they want you to multiply. So the answer, 8 times 9 is 72. All right. Now, they do a couple of problems in reverse. And so it looks kind of like this. 9 times the mystery number is 72.
9 times 8.
Okay, so instinctively, we can know that the n must have been 8. So it's, in a sense, it's in reverse. 9 times what? I've got the answer 72. And so the answer was clearly 8. Now, when we learn to do this as an equation, and this is an equation, what is an equation? It's got a left side, it's got a right side, and it's got equal in the middle. And what they want, they don't care about 9 times n, they want to know what n equals. One thing we can do to both sides is divide both sides by 9. And so for division, we would divide by 9, and we would do the same exact thing to both sides. So what happens when you divide 9 by 9?
Get
Get a
1.
1.
You get a 1. And so 1n is correct. But in algebra, they don't waste effort, and they just say, instead of 1n, they just say n, which means 1n. But over here, this is where we actually get the answer. 72 divided by 9 is 8. So I'm just showing you that. We'll eventually be doing that just a little bit. Okay. Now, last time we did problems like this. We did rectangles and we did perimeter. Do you remember that?
Yes.
So we went around the edges to add up the 4 sides on this rectangle. Now, what about area? Does anybody remember the formula for area for this shape?
Length times width.
Length times width multiplied, I'm going to go like that. Length times width. So if this was 10 and this was 4, let's call it meters just to be cute. So the area would be 10 meters multiplied by 4 meters. What would,
Don't see.
what would be the area?
40 meters.
40. 10 times 4 is 40. Now, what do you think happens with the meter?
It stays.
actually, interestingly enough, we multiplied 10 times 4 and we got 40. Everybody agree?
Yes.
We're going to actually multiply the words. Meter times meter is not meter. It's actually square meter. And that's the way you'll start to see it. Now, if you don't see it right away, you'll see it soon enough. We can say like that, meter squared, or once in a while they write it out in words, square meters. But the truth is, writing out the whole word square meters is kind of long, and m squared is easier. So we probably write m squared. Okay,
So how would you type that into the laptop? So like,
so if you don't have a button for, they will actually probably have something for you to click square meters.
okay,
So they'll have, they'll have a place for you to type in the 40. And then they'll have, is it meter? Is it square meter? What is it? And you'll just click on the square meter, which will then go to your answer.
okay,
They'll give you the choices, but you can type in, but they'll actually provide it so that you can bring it in nicely. In a pinch, and I wouldn't do this on the computer, but using this symbol here to the second power basically implies meter squared, but they're going to show it, they're going to hand it to you. Okay. Now area, what's good, what's useful for area? Well, if you had a wall and you were trying to paint it, you might be very much interested in painting the wall, right?
Mhm.
And you want to know how much paint? So I bought paint that was $50 a gallon or something stupid, some stupid number like that. You would want to get the right amount of paint, wouldn't you?
Mhm.
yes.
You would definitely want to get the right amount. And so I'm going to see if I'm pulling a problem from somewhere else. Let's say you had to paint this area, this place here. This is 6 inches. This one was 18 inches. This was 20 inches. And this was 8. It's not a rectangle. It's this crazy L-shaped. So when you have to do that, you have to break it up into recognizable pieces. And so what I might suggest is you could put a dotted line here, and then this bottom would be a rectangle, and this top would be a rectangle, and the total would be adding them up. So can you tell me, can you just visualize, just ignore this part and look at this? What is it? The length is 20. The width is,
8.
8.
so this one would be 20 multiplied by 8. 20 times 8 would be 160, right?
Yes.
How about this one? So you just look at this top piece. So this is 18 times 6. Well, I got 108. If I make a mistake, just tell me right away. 108. You like it? So this is 108. So what is the total inside this picture? What do you do?
Do you add them together?
Absolutely, because you want to paint the whole darn thing, don't you? And so it's
Yeah.
160 plus 108. And that's what you do when you have odd shaped things. So this is 8, this is 6. I'm getting 268. So now the question is, what's the correct unit? Now, I gave it in inches. So this would have been 20 inches multiplied by 8 inches. So 20 times 8 was 160. But what is inch times inch?
Inch square.
Inches
square.
squared. And when you do area, which is what we're doing, it's always square something. Square inches, square feet, square yards, square meters, square whatever. And so it's always square, so you don't have to guess. 268 square inches. The same happened up here. This was inch times inch was square inch. So it was square inch.
Wouldn't it be 6 times 10? Why did you do 6 times 18? Because I thought you were cutting the two.
Oh, we made a mistake. Thank you very much.
And then even just
Aha. It wasn't, this top one was not 18. 18 represented the whole darn thing.
Oh.
Oh, well, maybe we better revise our plan. We
Ah.
can. So from here down is how much?
8.
8.
So how much is this
Oh.
part? Oh,
10.
this is just 10. Redo this picture because that would certainly help us. The top part, I'm going to make it dotted. This is 10. This was 6. Then this went over here. Thank you. So this was 8 and this was 8. So now this was a total of 18 like it belongs. And this across the bottom was 20. Is this a better picture?
Yep.
Okay, so we've got part of it right. 20 times 8 is 160 square inches. That's that one.
And
But
then
this is 10 times 6, which is 60
yeah.
square inches. Oh, here's our new answer. 220
What?
square inches. You see how that happened?
Yeah.
Plan it, but it was actually a good thing to happen because then you see the error, right?
So
Because the whole thing was 18. And so when we just did this top piece, it was only 10 because this bottom piece was 8 already. Question.
yeah, so on the XYZ, I just checked 1.5 on XYZ. It doesn't actually have you do inches squared, or it doesn't
They don't
even
do this yet.
Yeah, they don't do that. They don't. I didn't see a button that
Okay.
that
If they
I
haven't
didn't see
done
a
it
powers
yet,
button.
that's okay. They will. Sooner or later, they'll
Okay.
do that. So don't worry about it for now, but it's good to know, right?
Yeah.
It's good to know, but if it's not there yet, that's okay with me. Okay. Let's see what else I've got. So the last thing, okay, so that's that problem. Let's do division. Do you think, I'm gonna do the strange one, division. The answer is quotient. 10 divided by 5 is one way to say division. This is another 10 divided by 5. If you had it with this symbol here, the 10 would be on the inside, dividing by 5 would be there. These are all division symbols. Everybody good?
Yes.
Now, 0 divided by 5. 5 divided by 0. 0 divided by 0. We need to deal with this. Which one has an answer?
None of them, they all would be 0.
Now, 0 is a perfectly lovely answer. If you were finishing paying off your mortgage, when you got to 0, you would be a happy, happy person. 0 is a a wonderful number. And so it is a zero, but one of them is 0. The others, not so much. So which of these 3 actually has the answer 0?
5 divided by 0 is 5.
No.
0 divided by 0.
This is the only good problem. The reason when you have division, there has to be a way to check it with multiplication. Remember how I checked addition with subtraction with addition? So if I had a problem like this, I'm going to do a completely different problem. 15 divided by 3 is 5. Everybody buy that? 15 divided by 3 is 5 because 3 times 5 is 15. Can you buy it? 15 divided by 3 is 5 because this number times this number is back to the original 15. Is that okay? I'm going to do another one or you have it. 20 divided by 2 is 10 because 2 times 10 is 20. So division and multiplication are tied to each other. Now, back to this problem. 0 divided by 5 is 0 because this times this goes back to the original thing. So 0 times 5 or 5 times 0 is 0. Now, 5 divided by 0 is what?
It's 5.
It has an
2.
answer. Then this number multiplied by this number should bring it back to 5. So that would mean 0 times the number we can't figure out is 5. What number works?
5.
It's 5.
5.
0 times 5 is 5.
0 times -5.
0 times anything is
0.
Is it 0 still?
No, because there's no way to get it back to 5. Once you have the first one is 0, 0 times anything in the world is not going to be 5.
It's going to be 0, right?
Nope. Because if I put 0 in here, it would not check, would it? It would
What
not.
if we do 5 times 0?
It's not going to work, is it? Can you multiply 0 times a number and get 5?
No.
No.
What,
We can reverse it and
This
divide.
is a problem that does not have an answer.
Oh, okay.
The way they call it is undefined. No answer whatsoever. Now, let's do this one, this last one. 0 divided by 0 is what? That would mean this number times this number. 0 times, I don't know what, is 0.
would it be 0?
I could put 0 in, I could put the number 17 in. I could put the number 312. I
I was
could
going to say,
every single number in the world.
I was either going to say it was like the answer is either 0 or like infinity.
There's every answer is good. Now let's think about this. If we had a math system that every answer would be just fine, how on earth are we going to get anywhere? You see my problem? We need a problem that has one answer, not every answer, because that's no good. So in this particular problem, we had absolutely nothing that would work. That's bad. In this particular problem, everything in the world worked. That's bad. This problem and this problem are bad problems. They are called undefined. And so some student once told me how to remember this after all this effort. Any number divided by 0 is a no. You like it?
Yeah.
Good as anything. So the number, and then it could be 0, it could be 5 or 12 or anything. Any number divided by 0 is a no. These are the bad problems. These are the ones we call undefined.
I have a question.
Is slip them in, and they're hoping you're paying attention when you see that bad problem. Question?
Yes, I had a question. So it's undefined. Does that equate to in the workbook where it says does not exist, DNE?
Does not exist.
Okay, thank you.
Does not exist. That's another way to say it. This is the fancy way. This is another way. It doesn't have an answer.
So do we type that for like if they try to trick us, we type in undefined or does not exist?
Yeah, they'll usually tell you what if they want this one, they'll tell you they want, that's one of your choices. This is the you know, also correct. They're both correct. There is no answer.
Okay.
And when you try to do this, if you actually tried to do it mathematically, it would try to go to infinity, which you can't get there. So I don't know. I'm going to tell you a quick story and then I want to move on. Star Trek, the original. I don't know if anybody watches that kind of thing. There was an episode where there was Star Trek. Is everybody familiar with this? So there was an alien being that had gotten into the computer of the spaceship. And so Spock, is everybody familiar with this?
Yes, I am. I'm
Spock
old,
figured
so I
out-
remember.
Put the problem into the computer. And the computer starts to have a meltdown. It can't do it because it's trying to go to infinity, which they can't ever get to. And so guess what the alien being does that was about to cut off the oxygen? It takes off. And so that they save the day with this problem. Can you buy it? I used to have people that actually knew all the episodes of Star Trek, and they said I didn't say it quite right, but that was the basic idea. You put the problem in to the computer couldn't do it and tried and tried and tried, had a meltdown, and the alien being went away. And so everybody was saved because of this problem. Yes.
It took a second for me to get it back.
Okay, whatever. Now, we want to do division, and I don't know how much trouble you've had, but you need to be able to do a little bit of this by hand. I don't know if you realize there's 4 steps in division. And when things go wrong, it's probably because you missed a step. And so the first step is division. So you divide 5 into 12. How many times does it go?
2.
Twice.
Okay. The second step is multiply. I'm going to abbreviate. 2 times 5 is 10. 2 times 5 is 10. The third step is to subtract. 12 take away 10 is 2. And the fourth step is to bring down, if there's anything left to bring down. And so then what happens is you repeat. So now it's 5 into 25 is 5. And then you're repeating yourself. 5 times 5 is 25. And then you subtract, and in this case, it was 0, and there was nothing left to bring down, and so you're basically done. There's your answer. So those are the 4 steps. Okay? Now, occasionally, all of this depends on knowing your multiplication facts. The real question is, do you? Let's try one like this. Okay. When it starts to be 2 digits, there's a little more of a challenge. And so sometimes the idea of rounding a little bit makes life simpler so that you make better guesses. And so this is 67, but I'm going to think of it as 70. This is 169. I'm going to think of this as 170. See, I'm doing a little rounding in my head. And so it's like 7 into 17. How many times would it go?
2.
2. And so it's got to go right here above the 169. So now we have to do a proper multiplication. 2 times 67. So 2 times 7 is 14, carry a 1. 2 times 6 is 12, and 1 is 13.
134.
Yeah. Remember, the next step was subtract. So if this has to be smaller than that, or you made a wrong choice here. But let's subtract. This is 9, take away 4 is 5, and this is 3. You've made the right choice if this number is smaller than that. That's smaller than 67. Now what we want to do is bring down. So again, it's sort of like, I'm going to do rounding, 70 into 350. So it's roughly 7 into 35, which is
5.
5. Now we're going to properly multiply. 5 times 7 is 35, carry a 3. 5 times 6 is 30. This would be 33. That looks good. I'm going to subtract, and it's just 15. There's nothing more to bring down, so we're basically done. The way they're writing their answer would be, the answer would be 25, remainder 15. And that's the way they'll have it. They'll write it at this stage. So there was 15 left over. Last time there was nothing left over. There's your answer with a remainder of 15. Is that okay? So this little bit, whether you like it or not, I think it's like you want to make a good guess. This might help. And if you guess wrong, at least then you could tell what's, you went too high or you went too low or something.
So would this be an acceptable, is this the exact quotient, or is this the remainder since we did rounding?
Well, no, I only use the rounding to make good guesses.
Okay.
But then this is the exact answer.
Do you have time to do one more?
It's so that when I started out, it's like, could I see that it was 2? This just helped me see that 2 had been a reasonable guess. And so I put down 2 for my first result. And when I multiplied it out properly, it was correct. It was 35 was left over, which was smaller than 67. So that told me 2 was the right choice. I brought down, and this was only because the numbers get larger. I wanted to sort of simplify it in my head so that I made a decent guess. This does not guarantee it'll be perfect, but it's as good as anything. It's right about 90% of the time, in my opinion. What do you think?
I should pay any more than mine paying.
Do you think we have time for one more?
We can go ahead. The class can be, if somebody needs to leave, we can do one more. What do you want to do?
One more.
Just a long division like that. I'm a little confused by your
Okay,
the
my
multiplication
rounding
and-
thing.
Yeah.
Okay, let me do this one. 71 into, I'm just pulling it out of a book. 16,620. Okay. So can you tell what's the correct way to get started? 71 doesn't go into 16, but we'll put a number here.
Okay.
Maybe you can tell what the correct guess is. My guess over here, my rounding was just to make a decent start.
Right.
So in my head, I was going 70 into 166 would be 170. Kind of like the last problem. 7 into 17.
Okay,
What do
yeah.
you think I should
Twice.
use? What number?
2.
2. Oh,
Okay. So that was just to help me make a good guess. At this point, I can throw that out. 2 times 1 is 2.
42.
2
No,
times
42.
7 is 14. Right?
My
Right.
God.
Now we subtract.
Now we subtract. 6 take away 2 is 4. 6 take away 4 is 2, and that's 0. So the 24 is smaller than the 71, so that's correct. So now we bring this down. So this is approximately 70 into 240. I'm just rounding that so that I can make a decent, making it simpler.
Okay.
7 into 24 would be what number?
3.
3.
4.
3.
4.
So 3 times 1 is 3, and 3 times 7 is 21. This is a borrow thing, right? Right here. So I'm going to borrow 1, the 4 becomes a 3. So 12 take away 3 is 9, and 3 take away 1 is 2. 29 is smaller than 71, so we're still good. I'm bringing down my last number.
Got it.
This is approximately 70 into 290. So that I can now see it's 7 into 29. What would be your number?
4.
3.
4.
4.
Like I said,
Oh,
it's
4,
not always right, but let's see. 4 times 1 is 4. 4 times 7 is 28. It's just right because this is smaller than that. So when we subtract, it's a borrow. And there's only 6 left over. So
that's the first time in my life I've seen it explained this way. Honestly.
this thing, and I'm going to give you a fancy word, but I like this word. This right here is an algorithm. You can do a problem making 1,000 steps, but if you want to do it in the most precise way, you follow this 1, 2, 3, 4, and repeat. This is like a computer program. 1, 2, 3, 4, and repeat. And so that's, the fancy word is algorithm, but it's mathematically good. So your answer would be 234, remainder 6.
Okay, that was really helpful. Thank you.
Okay, so it's a little bit after 11:30. What I'm going to do, first of all, I'm going to get out of this. I'm going to stop the recording.